right, section 8.3 will be about multiplying and dividing rational expressions. We just spent some time graphing, and now we're going to talk about how we simplify and multiply, divide, work within those rational expressions. So here's an example of and reminder of some things we've done. Simplifying rational expressions. You want to factor the numerator and denominator, which is what we've been doing. Should be familiar with that. To simplify a rational expression, divide the numerator and denominator by a common factor. That will help. So let's go and let's factor. In this example, if we look at it, we've got nice trinomials, and they're nice easy ones. So here we go. What multiplies to give me negative 18, that adds to give me a negative 7. You've got the x and the x, and then we're looking at a 9. Looks like we need a 9 and a 2, and it looks like we need a positive 2 and a negative 9. That looks to work. Now, FOIL it back out to double check if you're unsure. And then on the bottom, we've got x squared minus 8x minus 9. Again, we need x and x to lead us off. And then what multiplies to give me negative 9, that adds to give me negative 8. That looks like a negative 9 and a positive 1. So when we say simplify this, we factored it, and now because everything is multiplication, the rule is you should be able to cancel. So I'm just a fraction, so put me in lowest terms. Well, if they have that common factor of x minus 9, it can go. A remainder of 1 is there. So all we have now for our final answer is the binomial x plus 2 over x plus 1. Now, I like to get in the habit of putting those back in that binomial, in those parentheses, sort of to lock them in and think of them, I am a single term, even though I'm a binomial, because there tends to be some people who want to cancel these x's, and that is not a good thing. You cannot cancel the x's unless the whole quantity of x plus 2 would cancel with another quantity of x plus 2. So our final answer here would be the fraction x plus 2 divided by x plus 1. Next, when we want to multiply rational expressions, I have down, it's exactly related to multiplying rational numbers. So I have a couple examples here. When you did 24 fifths times 35 thirds, you learned a couple things. This one has no variables in it, but let's go. With rational numbers, we would say something like 5 goes into 5 once, 5 goes into 35 7 times. We could do what we call cross-canceling. On the other diagonal, we could say 3 goes into 3 once, 3 goes into 24 8 times. The rule is top times top, bottom times bottom to multiply fractions. So we're left very easily, no calculator needed, with 56 over 1, better known as 56. Okay, we can do that same sort of thing if we only just add a few variables. So again, any numerator to denominator can be canceled. It does not matter whether it's straight up and down or on the diagonal. So there's lots of choices here. If we go through them, start looking at them, I've got a 5 here and a 5 here. Now I'm not canceling the x with it, just the 5. I have a 6 up on top. 6 goes into 6 once. 6 goes into 18 3 times. I have an x up on top here that's gone, and that'll take one of my x's away here in the denominator. Okay. That also leaves me a couple other things, and you can cancel more than once, so here we go. I have a 3 left down in the bottom. I have a 9 on this top, so 3 goes into 3 once, 3 goes into 9 3 times. I have x to the 5th up on top and x to the 6th in the denominator. So x to the 5th is gone. That leaves us with 1 x remaining. And I double check. I see everything on top has a 1 with the exception of the 3. Everything on the bottom is done except for the 3 on top and the x on the bottom. Now let's go and do the same thing with these trinomials. Let's factor the bottom first. Actually, let's move it up so we can see them. And let's factor the bottom first. We would get what multiplies to give me a negative 12 that adds to give me a 4 in our trinomials here. That looks like it should be a plus 6 and a minus 2. That looks like it works. In the denominator again, what multiplies what multiplies to give me 30 that adds to give me 11. I think our 6 and 5 will do it on that one. So x plus 6 and x plus 5. We're multiplying, so we're good. Go to the other trinomials. What multiplies to give me negative 35 that adds to give me negative 2. X and x looks like a negative 7 and a plus 5. And then our binomial on the bottom can't be broken down, but I definitely would put the locks or parentheses around it to keep it together so you're not mis-canceling, reducing any of these things. So start looking, just like you did with the numbers, do we have any quantities that are numerator to denominator combinations that can be canceled? And I see a couple, hopefully you do too, like the quantity of x plus 6, one in the numerator, one in the denominator, they're gone. Another factor of x plus 5 and x plus 5 in a numerator-denominator combination. And after that, that looks like all we can do. So if we want to leave it in factored form, we'd have x minus 2 times the quantity x minus 7 up on top. Top times top, bottom times bottom. Don't know what happened with the pen there, so let's clean that up a little. All right, here we go. X minus 7 all over the x plus 4, which we couldn't cancel. If it says write a rational expression, then you are going to have to finish that a little, and that would mean FOIL out the top, and we would get x squared. Outside's negative 7, inside's negative 2. Added together is negative 9x. Last times last is a positive 14, and that would be all over x plus 4. So there's a good example of how you would multiply. Obviously, after we multiply, we should know that we can divide. And dividing is just like our rational numbers also. You should have learned that you never divide with fractions. You always multiply by the reciprocal. So you should be rewriting this as 24/5 times, flip it, the reciprocal would be 35/3. And again, from there, you would do your canceling. 3 goes into 3 once. 3 goes into 24 8 times. 5 goes into 5 once. 5 goes into 35 7 times. Top times top, bottom times bottom. You could leave that as a 56 if you so choose. On a triple like I have here, you would definitely want to use the idea of the first one stays the same, so 9x to the 5th over 5. Then each of these ones that are division turn to their reciprocal. So we'd have x to the 7th on top over 6 times 18 over 5x. And then you would just cancel any numerator to denominator combination, and you'd be good to go. All right, let's do this rational one. That is a little more like what you're going to see tonight. So here we go. In the numerator here, you're looking at, that's difference of squares, a little different than our trinomials. So you should be thinking of x plus 5 and x minus 5. In the denominator, because the first fraction, remember, always stays the same, you should have an x plus 3 and an x minus 1. Remember, what multiplies to give you the last term, that adds to give you the middle term. Then it's our division sign, so we got to be thinking times by, now the reciprocal. So we want to flip this, and I only have a binomial up on top, so that binomial would now be what's in the denominator. Up on top, we got to be thinking what multiplies to give me negative 18, that adds to give me negative 3. And we've got our x and our x. And it looks like we need a negative 6 and a positive 3. Now, after you have it completely factored, then and only then do you want to start canceling. So start looking. Any numerator to denominator combination can be canceled. So I'm looking at an x plus 5 in the denominator here with an x plus 5 in the numerator. They cancel and we get a 1. How about the x plus 3 in the numerator up on the right with the x plus 3 in the denominator on the left? I don't see anything else, again, that can be factored or canceled, sorry. If we say x minus 5 times x minus 6 remains up top all over the quantity of x minus 1. We are done unless, again, they ask for a rational. Then you would just FOIL it out and you would have your x squared minus 11x plus 30 up on top with your quantity of x minus 1 in the denominator. So if they want rational polynomials, you're going to have to leave it like that. All right, I believe we got one more thing for you for tonight, and that is how do you take something that is a complex fraction and rewrite it. We know the definition of a complex fraction is nothing more than a fraction within a fraction. But if we have fractions that are polynomials, that sort of makes it a little tougher. But I think we'll be fine. Using our division rules, we will just have to do our factoring, rewriting. So here we go. On this one, our first term is that b squared minus 4 divided by b squared minus 2b plus 1. So that's going to be our numerator-denominator combination. Then we've got the division sign, so that's like our big division. And we never divide, we multiply by the reciprocal of the second one. And our second fraction is really made up of binomials, so our reciprocal becomes b minus 1 and b plus 2. They do get flipped. So now let's just go back to that first one, finish our factoring, and we should be good to go to finish multiplying. B squared minus 4 is a difference of squares, so we're looking at b minus 2 and b plus 2. In the denominator, we need what multiplies to give me 1 that adds to give me a negative 2. I think that's an easy one for you. And now, again, looking at what you have, the combination you have remaining, numerator to denominator combinations are the only thing you can cancel. So b minus 1 up on top right gets canceled with b minus 1 on the lower left. B plus 2 on the upper left gets canceled with b plus 2 on the lower right. Numerator to denominator combinations, and in this case, the only thing remaining after we cancel the quantity of b minus 2 on top over a b minus 1 on the bottom. Again, be careful. You can leave it just like that. If you put it in parentheses, that reminds you that they're sort of locked. They go together. You cannot reduce them. You do not want to cancel the b's here and leave it, for example, with a negative 2 or actually a positive 2 because a negative divided by a negative. You definitely do not want that. So we can check our answer and we're good to go. We approve, it works. So you're going to have rewriting, you're going to have a lot of review with canceling and fractions, and also your factoring. That is not going away, notice. So be careful in your combinations, and most of your answers will need to be in rational form, so multiply them out. If you have any questions about this or what I was doing here, bring those questions with you to class.